Hey everyone! So today we're going to do a fun problem and we're going to try and find all of the permutations for a given input. So for example, we have here the input is a list of integers, which is 1, 2, 3. And as you can see, we have all of our output is all of the different ways that we can rearrange those integers. So we're going to just go ahead and dive right into this problem. So the first thing that's really important that we do here is that we ask, what are we making permutations of? And this is, in a lot of problems, I say this all the time, and it's, more or less necessary in different cases, but in this case, it's really, really important. And the reason is that it's going to completely change our implementation of the problem. For example, if the input is a string, which is basically an array of characters, and so we want to, for example, if we want to rearrange all of the characters in the string and have all different possible strings made with those characters, it's a much, much easier problem for us to implement than using arrays. And we'll see why, because we're going to go through the implementations of both. And it's the same idea, it's the same process that we're going to follow in both cases, but some of the properties of strings, like their immutability, are going to make it much, much easier for us to do the one than the other, and it's just going to take a lot less code. So without further ado, let's go ahead and dive into how we're actually going to solve this. And when you see problems like this, the easiest way that you should probably think of to do it is recursively, and the reason for that is just that we can break this problem down into saying that, for example, this is 1 plus both permutations of 2 and 3. And this is 2 plus both permutations of 1 and 3. And this is 3 plus both permutations of 1 and 2. And so obviously we can define this recursively by just saying that we're going to go through all first possible items and then recursively get all of the possible combinations of all the following items. And so that's basically how we're going to solve this. And I'm actually just going to go ahead and dive in, and we're going to look at the string implementation of this, and hopefully that, if it's not clear already, is going to start making a little bit more sense. So with the string implementation, it's going to be basically the same as what we have here for the integers, except that we're going to get strings back. So it's going to be like ABC, ACB, BAC, etc., etc. So I'm going to go ahead and remove this for now. And then, so let's go ahead and we'll define a public, and we're going to return a list of strings. So in this case, I'm going to use an array list because the dynamic sizing is going to make it much, much easier. So an array list of strings, and I'm going to call it permutations, and it's going to take in a string. So far, so good. And we're going to call another function recursively because this will just be our public function for our interface that we're doing. And so we're going to have a private void, private void permutations. And that's going to take in, so what we're going to do is we're going to take in a prefix, and we're going to take in the remaining characters, and we're going to take in an array list of the results that we're going to add our results to. So the idea is going to be, if you take this example here, we're going to first say that prefix equals the empty string, and string, or we could say suffix, is going to be equal to ABC. And now what we're going to call recursively, so we're going to call permutations of A and BC, and then we're also going to call it for all the other combinations. And that way, we're going to, each round, we're going to append on one character to our prefix string and remove that character from the suffix string. And that way, we're going to end up with, once the prefix string is full and the suffix string is empty, we're going to end up with one possible permutation. So if we go back to here, we have string prefix, string suffix, and array list of strings. And that's going to be called results. So what we're going to do is first we want to say, are we at the end of, we want to define our base case for our recursion. So we can just say if suffix.length equals 0, right? Because once the suffix is 0, there are no more characters that we can append or want to append onto the end of our prefix. And so we know that we're done. So and that the prefix is the entire permutation. So we're going to say if suffix.length equals 0, then we want to add our prefix to the results. So we're going to just say results.add prefix, just like that. And then otherwise, we're going to recursively call our permutations on all of the possible prefixes with one of the characters in the suffix list appended to them. So we're going to say, we're going to call it on, for example, we're going to say, if we go back to our example where prefix equals the empty string and suffix equals ABC, then we're going to call permutations A, B, C, and we're also going to call permutations of B, AC, and we're going to call permutations of C and AB. So we're going to say for int I equals 0, and we're going to go through all of the characters in our suffix array. So I equals 0, I is less than suffix dot length, and I plus plus, and we're going to get the character. So we're going to just say permutations of prefix plus suffix dot get dot car at I, right? Suffix dot car at I. And then we also have to pass for our suffix string, we have to remove that character. And so this is something that is really easy to do with strings because they're immutable, but is not so easy to do with arrays. And this is going to be part of the complication that we're going to have to deal with later, where each time we do this, when we do prefix plus suffix.car at I, it's going to generate a new string. And so we don't have to worry about having a reference to the same string and accidentally modifying the string because strings are immutable. And that's going to be the problem that we're going to run into and we'll have to deal with later with the arrays. But for now, we can just create a new suffix string by doing suffix dot substring 0 through I, because it's not inclusive, so that's going to be up to I, and then plus suffix, I'm going to break this onto a new line, suffix dot substring I plus 1 through S suffix dot length. And that way, we're going to create a new string that is going to be all of the remaining characters except for the character that we put in our prefix. And then we're going to close this out and we're going to just finish this up. And that is all we need. And finally, we need to come back here and we need to actually call it. So we're going to create a new array list, which is going to store our results. So that's going to be string results equals new array list. And then we're going to call permutations of, and remember that we are starting with our prefix being the empty string and our suffix being the input string. So empty string S and results. And then finally, we're going to return results. So hopefully this makes sense. You can see that what we're doing is we're going through and we're getting one character. We're starting with an empty prefix, and then we're adding each character as we're going through all the possible characters and adding that character as the first, and then appending all the remaining permutations on. And I'm not going to actually go through and test this, but you could do that on your own time, because what I'm going to do now is we're going to generalize this a little bit. So this is where the problem gets a little bit trickier. And so we're going to go back here, and I'm going to use arrays of integers, but you could do, you could do this generically if you want, or you could do arrays of whatever else you want. So we're going to return an array list of integer arrays here. And that's going to be our, basically a array list of all of our permutations of the integer arrays. So we're going to end up with, however many arrays of integers with all the different possibilities. And I'm going to call it permutations. And I'm going to take in an int array that I will call A. So that's all fine. I'm going to go ahead and get rid of this stuff. Let me go back actually to our example that we had before. So 1, 2, 3. We're going to end up with 1, 2, 3. 1, 3, 2, 2, 1, 3, etc. So let's think a little bit about how we're actually going to solve this problem in this generic case, because it's a little bit more tricky than the strings. You can't exactly say, or you can, but you can't efficiently just take the prefix of the array and the suffix of the array, and it's not so easy for us, or so efficient for us, to just take our arrays like this and combine them and split them and whatnot. So we need to think of a slightly alternative approach. And the approach that we're actually going to use here is that we're going to keep everything in one array the entire time. And we're going to use a pointer in the array to tell us where our prefix and suffix are. And then we're literally just going to rearrange items in the array to represent the prefix and suffix. So let's just go through an example here. So we're going to start with the pointer pointing to the first element in the array, or we're going to basically iterate through all the elements in the array, and we're going to have some pointer that says where the prefix or where the suffix starts. So first, it's going to start at the first item. And then what we're going to do is we're going to swap this item with each of the successive items and call the permutations, and then increment this and call permutations on it. So let's look at the first example. We swap this with itself, and then which is the first case, and then we increment the pointer. And then we swap this with itself and increment the pointer, and then we swap, and then we swap this with itself and nothing happens. So basically, our first permutation is just the array itself. But now let's look at the slightly more interesting case. So we are going to swap this with the second one. And then we're going to increment our pointer. And then we're going to, actually, let's go back a second. Really what we're going to do, if we want to go in order of the recursion, is we're going to swap it with itself, and then we're going to come back to here, and we're going to swap this with the third one. So we're going to swap these two, and then we're going to come to here, and then we're going to return this string, this array. And then what we have to do, which is important, is we have to make sure that we undo these swaps. So we're going to now go back, and we're going to do the same swap again. So we're going to go back to here and do the same swap again, which is going to revert to where we were, and then we're going to come back to here. And now we are going to swap this one with the second one. So we're going to swap like this. Then we're going to increment to here. We're going to swap it with itself, and we're going to swap this one with itself. Then we come back to here, and we swap this one with the next one. So we're going to say swap them like that, and then come here, swap it with itself. And then we have another one. So we're going to go back, and we're going to swap these again to go back to what we were at before. And then again, we're going to back up one, and we're going to swap them again. So what you can see we're doing, it's a little unclear. It may be a little unclear, but hopefully it'll make more sense as we're going through the code. We're going to keep swapping them. And then we're going to, once we get to some final state, we're going to make a copy of that array, and we're going to put that into our list. And then we're going to go back, and we're going to revert the array to its original state and go through the next iteration. So let's go ahead and we're going to define our private void permutations. And that's going to take in our int array A. And it's going to take in an int start, which is going to be our pointer. So int start. And finally, it's going to take our array list of int arrays called results. And now what we have to do is actually do this recursively. So the last thing I will do before we actually do that is I'm going to define a swap function, because we're going to use this twice in every iteration, in every methods, or in every call of permutations. So it's going to just make it a little cleaner to break this out into its own method. But all it's going to do is it's going to swap to indices in the array. So we're going to say int A, int I, and int J are going to be our two indices. And then all we're going to do is, it's the standard swap. So temp equals AI, I equals AJ, and AJ equals temp. And we're not going to worry about checking for, valid input, because we're going to be calling this only internally. So, I'm just not going to worry about it. But we're going to come here now, and what we want to do is we need our base case, of course. And so our base case in this case is going to be when our start pointer is at the end of our array. So we're going to say, or really when it's past the end of the array. So once the start is greater than or equal to the length of the array, then we're going to know that we've gone through and done all the swaps we're going to do. So we're going to just return our array. So we'll say if start is greater than or equal to a.length, then we're going to then what we're going to do is we're going to add our results to our current array to results. So we're going to say results dot add a. And actually, so hopefully you see that there's a slight problem here. And that problem, which we've sort of discussed earlier, is that A is just a reference to the array. And so A is going to continue to get modified throughout the rest of this code. So what we really need to do is copy it. And I'm just going to copy the object by doing a.clone. And there are multiple ways you could do this, but this is just a really simple solution. And you can do whatever it is that you prefer, but this is going to make it so that we now have a separate array in our results array list that is completely separate from the array that we're going to continue to manipulate. And so otherwise, if we're not at the end, we're going to call so first we're going to do a swap, right? We're going to say, we're going to go through all of the remaining values in our array. So let's go back to here. We're going to go through all possible values to swap with the first one. And then we're going to go call that and go through all possible values to swap with the second one and then the third one. So we're going to say for int I equals 0, I is less than a.length. And I++, we're going to say that we're going to swap A, and then we're going to swap it with start. We're going to swap start with I. And so this way, we're going to get all of the possible values at our start position. So it's going to go through and it's going to swap each different value with start. And so we're going to get all possible values set to start, and then we're going to call permutations on the suffix of that, basically. So we're going to say then permutations of A and start plus 1 and result. Right? And then finally, we want to swap back our start and I. So this is going to revert the array back like we were talking about, so that we're never actually completely messing up the array, because otherwise we might get some duplication and miss other possible permutations. So that's going to be all there is to that. And finally, we just need to call our permutations, our recursive function. So we're going to say we're going to create a new array list of ints. That's going to be our results list equals new array list. And then we're going to call permutations on that list of A0, because we're starting with, it's basically the empty string that we had before, and results. And finally, we're going to return results. So let's go ahead and we're actually going to test this. So let's just represent, we're going to test, we can just test on this basic example that we have here. So we're going to say that our results is empty. And then we're going to go ahead and we're going to say that A equals 1, 2, and 3. And so let's go ahead and we're going to, so we call this with A, we create a new array list, and then we call permutations of A, 0, and results. So, and then I'll just put start here equals 0. So first, start is not greater than A.length. And so we don't do anything there. And then we say for I is 0 through I is 3, right? So while I is less than 3, then we're going to, first we swap A and start. So let me just put I here, I equals 0. So we're going to swap A and start, which is we're going to swap these, and then we're going to call permutations on start on A, start equals 1, and result. And then we're going to come back to here and we're going to do it again. So A start with start is not greater than or equal to 3. So we're going to come down to here and we're going to say I equals 0. So now, I still equals 0. And we're going to swap A and start. So now we're going to swap start and I. So I is 0 and start is 1. So I is 0 and sorry, there's actually a bug here, right? Because if I is 0 and start is 1, which doesn't make any sense. So what we actually want to do is we want to start our count here at start. So this is going to mean that we're only going to be looking at the end of the array, right? So that's not going to affect us the last time because start would have been 0, but now start equals 1. So we're going to swap in A, we're going to swap 1 and 1. We're going to swap 1 and 1, which is not going to do anything. And then we're going to call permutations again. So we're going to come back to here. Start is equal to 2, which is not greater than 3. So we're going to come down. We're going to say now start is 2. So I equals 2. And 2 is not less than 3. And so we're going to swap start, which is 2, and I, which is 2. And so we're going to swap this with itself again, which does nothing, and we're going to call permutations and start plus 1. So now start equals 3, and 3 is equal to A.length. So we're going to say results.add A, or clone of A. So we're going to say, put 1, 2, 3 in here, just like that. And then we're going to return back. So now we're going to swap again. We're going to swap 2 and 2. So, we're going to break out into our previous iteration where start was equal to 2. And now we're going to swap 2 and 2. And then we're going to now come back to here and we're going to say that we're going to pop out again because I is equal to 2. I is equal to 3 now, and that's not less than 3. So we're going to come out, and now start is going to be equal to 1. And hopefully you're keeping track of this. It's a little bit tricky without being able to draw very clearly, but maybe I'll also put So our start now is here. And now what we're going to do is we're going to come back. And so I is now equal to 2 because it was 1 and now it's 2. So 2 is less than 3. So we're going to swap A. So start is 1 and I is 2. So we're going to swap these two elements just like this. And then we're going to call permutations of A. Start is going to be equal to 2 and results. And so we're going to come in here again and we're going to say we're going to increment this by 1. So now we're here. And again, we're not going to do anything basically. So start is going to be equal to 2 and A is less than A.length is 3. So we're going to come down here. We're going to swap it with itself. We're going to call permutations, which is going to start is then going to be greater. So it's going to add this array to results. So we're now going to add 1, 3, 2 like this. And then we're going to break out of this. We're going to swap this back with itself. Then start is going to be decremented and we're going to swap these back. And now we're going to, now start is going to be equal to 1 and I is going to be equal to 3, which is not less than 3. So we're going to break out of that loop too. And we're going to come back another one. And now we're going to swap this back with itself, because if you remember here, it was I equals 0 and start equals 0. So we were going to swap it with itself. And now we're going to go to I equals 1. And so I'm going to go through like one more time through this, but you should go through it on your own because it's a little bit tricky for me to explain it without being able to draw it out. But we're going to come down here. I is now equal to 1. So we're going to swap start with 0 and I is 1. So we're going to swap 2 and 1 like this. And then we're going to call the permutation. So start equals 1. We're going to increment this like this. And now start is not greater than A.length. We're going to, we're going to do the same thing as we did before. We're going to swap this with itself. We're going to increment this. We're going to swap this with itself. And then we're going to get to here and we're going to add this to our results. So 2, 1, 3. And then we're going to come back here, swap it with itself, come back here, swap it with itself. And then we're going to increment I. So we're going to swap this with the next one. So we're going to swap these two, come to here, add this to our results. So 2, 3, 1. And then we're going to come back to here, swap it with itself, come back to here, swap these two, which is going to make 1 and 3, and then come back here and swap these two, which is going to be 1 and 2. So as you can see, at the end of each iteration, we're always coming back to our array that we expect. And then, lastly, we're going to swap this with 3. We're going to come here. We're going to do the same thing. We're going to swap it with itself, come to the end. We're going to come back. Oops. We're going to come back. We're going to swap this with 1. And then finally, we're going to swap this back. And then we're going to swap these back like this. And all along, we've been adding it to the results. And hopefully you can see that this works as expected. And again, I encourage you to go through and try it a bit more on your own. But this is a really good problem for you to know and have under your belt because it's a super popular problem to have asked. And it's a very common thing to want to do. So it's good to know how to do this. Hopefully that all made sense. If it didn't make sense, just let me know in the comments and I'll be happy to explain further. So I will see you again soon.